Abellon, which is a fantastic Indian company doing waste to energy plus. So today we're very lucky to have Mr. Aditya Hunda, who's the Managing Director and CEO of Abellon, and some of his colleagues to join us, who can introduce themselves in the question time. I had the pleasure of visiting one of the facilities in India earlier this year, and one thing I like about the way that they work is that they leave space for the additional circular economy activities that we talked about in the handbook Waste to Energy in the Age of the Circular Economy nearly 4 years ago. So this is a wonderful company. I'm really looking forward to it. Aditya, are you there?
Yes, I'm here. Thanks for the
I'll
introduction.
hand over to you, sir. The floor is yours.
Thank you. Thanks very much. So let me first say that it's a privilege to be here on this platform. So thanks to Steve and everyone at ADB for giving us the opportunity. I'm just going to share my screen and put up a small presentation. I hope it's visible.
Yes, it is.
Okay, thank you. So I think before going into what we do as Abellon, if I try to define the problem that we're going to solve as a business, I think it starts by saying that waste is a very unique pollutant. All of us understand environmental or air pollution in terms of greenhouse gases, but waste is unique because it's very local and it's more acute. So what you see on the left is a particulate matter, 2.5 and PM10, and you see it in reference to a human hair, and you can see how small it is. And these particles are being inhaled every day by everyone in our big cities, and they have the capacity to infiltrate the respiratory system and lead to all sorts of issues. Unfortunately, these particles tend to affect growing children the most, so they're responsible for stunting growth, which is a big sort of challenge for society. And in the Indian context, we have some of our cities are amongst the most polluted in the world, and it's now proven by good science that waste or waste burning is between 1/3 and 1/4 of the problem, depending on the season. I think equally, this is a problem that's growing very rapidly in India. So you will see here that India generates about 62 million tons of waste a year, which is much lower than China, the European Union, or the US. On a per capita basis, we are only about 0.5 kg per capita per day. Whereas if you look at developed economies, they are anywhere between 1.3 to 2.4. So all of us know that this problem is going to grow. This is a side effect of prosperity or progress. So as urbanization grows, as per capita incomes grow, as consuming habits change, there is going to be more waste generation. India is also unique in the sense that we have about 40 cities, which are the big waste generators, I would say. But we also have 1,000 more cities, which are small today, but which are also growing very rapidly. And they are going to become big sort of waste generators also. And so it's up to us to think of solutions for those cities also today. I think it's important to take a more sweeping view of how waste management systems evolve. And you will see here a correlation between per capita income in a country and the level of waste management. So in India, we are one of the largest economies of the world, but given our population, our per capita income is still pretty low. And you will see that most low-income countries still rely on open dumping, which is also what we do in India. And as a country becomes more and more prosperous, there is a move to both recycling as well as to energy recovery. You will see that in India, we are actually not doing that bad on recycling because of the strong informal network of recyclers that we have in our country. I think in India, waste is also a problem of materials. And what do I mean by this? So as an economy in India, we use close to 10 billion tons of materials today. And this is all your materials from steel, cement, sand, plastic, you name it. This is all the materials used to make all the stuff that we need. Now, interestingly, in the next 20 years, this is going to become 30 billion. And it's just not possible to keep growing at this speed with the current model of extracting materials or manufacturing materials. All of us know that has an environmental cost, it requires a lot of energy, and therefore the only solution is to make as much of the economy circular as possible so that we can recover some of these materials again and use them again. To this effect, you will see on the right that if I look at the trajectory of waste in India, more and more recyclable or valuable materials are coming to the waste. So for example, if you see the trajectory of plastic, you will see that every decade, there is a significant growth in the amount of plastic that we are getting in the waste. On one side, it's not good news, but on the other side, it's an opportunity to recycle most of this material and put it back in the economy so that we don't have to extract the 30 billion tons of materials that we need going forward. This also has an implication on the carbon footprint of the country. So you will see, the total carbon footprint of India on this graph, and the parts you see on the left, which is all the energy and all the materials and all the transport, is actually in service of manufacturing stuff. So you are extracting or manufacturing or transporting a material. And hence, if you make it more and more circular, you will use less and less of this and hence emit lower and lower amounts of carbon. Not many people realize this, but if we look at the cumulative effect of each initiative in terms of reduction of carbon emissions, the first one all of us understand is renewable energy, which our country is doing in a big way. But the second is actually material circularity. Whenever I ask people to guess what would be a close second, people usually say electric vehicles or something like that. But the second is actually material circularity. So this just shows how important this is in a country's strategy to become net zero. When we talk of material recovery and energy recovery, I think there's been a lot of discussion that energy recovery is not good. Energy recovery inhibits recycling and it should not be encouraged. I think the data very clearly shows that if landfill is considered as the worst possible outcome, which it probably is, and energy recovery is the next best outcome, and recycling is the very best outcome, then energy recovery in most countries really competes with landfill, not so much with recycling. There are good reasons for this. I think if you can recycle a material, it is generally economically more valuable to recycle as compared to just recover energy. And hence energy recovery can be applied to most of the non-recyclable waste, which would otherwise have gone to landfill. So as a country, as we make our policies and plans, and as a company, as we make our business plan, we are learning from these global trends as to what has already happened in the world to see how can we best adapt our plan to the given situation. If you take an example of a country like Sweden, we see through different steps and a trajectory over 30 years, Sweden was able to come to a zero landfill type of level. And in the Indian context, essentially what we are trying to do is achieve in 5 to 10 years what European countries took 25 or 30 years to achieve. And this is the technology leapfrog that developing countries get an advantage of. So if you take the example of the telecom industry, in India, everybody had a cell phone before they had a landline. So this is the leapfrog that exists where we can take advantage of the new and emerging technologies in the West. So I think we have begun to do that. And this slide will tell you the various initiatives that the government of India has taken in terms of creating policies for waste management. And these policies are stratified across various levels of policy making. So at the apex, obviously, you have the Niti Aayog, which is the policy think tank. You have the Prime Minister's office. You have the courts, the National Green Tribunal, which has come down very heavily on waste pollution. And then you have the ministries that deal with the subjects. Now, this is a little complex because waste is a multifarious topic. So to handle waste, you need the urban ministry, which manages the cities. You need the environmental ministry, obviously, but you also need the energy ministry, which would buy the electricity. So it's a consensus building process of 3 or 4 ministries, which have to come together to make a policy, which is not easy. But I think in India, we have made significant progress to be able to do this. You will see the policy initiatives, which lays out all the regulations that exist. I think to explain these in a nutshell, what the Indian government is trying to do is say that if a business comes in and develops a waste project, we will first of all de-risk the offtake. So if we generate electricity from waste, the government will buy all the electricity. If we generate biogas, the government will buy all the biogas. If we recycle plastic and create granules, the government has come up with EPR regulations where it's compulsory for businesses to buy those granules. So I think in one form or the other, the government has clearly said that they will de-risk the output of such projects. And on the other side, they've said that they will take care of the economic viability of the projects, which is through feed-in tariffs, which is through capital grants, which is through tipping fees. And this is being done across both municipal waste, which is the sector we operate in, but also across industrial waste, agro waste, and all the other areas of waste generation, which ultimately affect air quality. Similarly, the government is acutely aware, and all of us in the country know that the next 1,000 cities are going to be the big challenge. I think the first 40 cities are big, they have resources, they have governance, so they will get their act together. But the next 1,000 cities are what we need to support. And to that effect, a cluster-based policy has been created, where if each small city cannot afford a large project by itself, then 3 or 4 or 5 such cities can come together, form a cluster, and pool all their waste at a central location, and then set up a project jointly at such central location. We as Abellon are also participating in some such cluster-based projects. Coming to what we do as a company, so our plan is very clear that we want to do an integrated waste management process, which creates as much of a circularity flow as possible. And the starting point of our projects is energy recovery, waste to energy plants, because these plants are the most proven, have the longest track record, are the most scalable, and can really deal with waste which is not fully segregated. So our first sort of go-to project is a waste to energy project, but we realize that waste to energy is suitable only for the 45% or so non-recyclable waste, for which energy recovery remains the best solution. And hence what we are planning over the next 3 to 4 years is add-on projects of biogas. So to really sort out the wet waste and generate biogas from it. And we are already sorting out some plastic, and we plan to sort out even more of the plastic and create recycled plastic granules, which would go back into the economy as a material stream. So as a company, we have a very clear view of a starting point, which is waste to energy, but a growth plan which encompasses all areas of integrated waste management. And we feel we will be able to, at the end of this, reach about an 85% level of circularity for the materials that we handle. We have about 45% of Gujarat's municipal waste under concession to us, the 4 biggest cities in the state. And once we get our Gujarat model fully complete, we hope to replicate this across the country in other states also. So Gujarat's first waste to energy plant in Jamnagar got commissioned in May of 22. So we have about 2 years of track record now, and the plant is running quite well. I think there has been questions or apprehension about whether Indian waste is suitable for energy recovery, for recycling. And I think our Jamnagar project, as well as many other projects in the country, have proven that the waste to energy model can be a success in the Indian context. I think to give you some highlights of this project. So this is the first project in Asia, to our knowledge, to get IGBC Platinum certification. So it's a fully green campus. This is the first project in the country to have more than 80% domestic technology or indigenously developed technology, which I think is a credit. And as a country, if we want to build more than 200 plants over the next 10 years, then I think we need homegrown technology, which our company has been doing. This is also a project that operates in a cluster mode. So Jamnagar is the anchor city and the biggest supplier of the waste, but we also get waste from several cities around this, which is the cluster theme that I spoke about earlier. And this is also a project that uses some stream of what is called biomined waste. So this is the mountains of waste that exists in our country today. And with the initiative of the government, these are getting biomined now. So all the combustibles are getting recovered. And these combustibles go to cement plants to be incinerated. But now waste to energy plants are a second alternative for suppliers of this biomined material, where we can accept this material and dispose this scientifically as well. So if I speak of our plan, I think the starting point, as I said, is the first circle, which is waste to energy. But you will see several concentric circles of how we want to expand our business. I think the next one is EPR, or extended producer responsibility. I think the regulatory view in India is very clear that we have to follow polluter pays. And we have to think broadly about who is the polluter in case of waste. So one type of view can be that it's the municipal corporation or the city, which is the polluter. And so the city has to pay a tipping fee for this material. But if you go one step back, the city didn't generate the waste. It was consumers like all of us who used products which became waste. So then it's the consumers who are, the polluters. And so we have to pay. But if you go even one step back, then we consume the product because somebody made the product. And the choice to use a certain type of packaging or make a certain type of product was really that of the producer. And so it's the onus of the producer to make sure that the end disposal happens and the full life cycle is completed. There has already been EPR announced on several materials in India like plastic, rubber, used oil, e-waste, and there are many other such guidelines in the pipeline. So I'm sure in the next few years, almost all materials will get covered by EPR. And through our waste management activities, it will become both a good revenue stream for us as well as a good point of service to fulfill compliance needs of our customers. Similarly, along with municipal waste, we intend to blend a certain part of non-hazardous industrial waste of a similar nature. And that's another service point which we can provide to our customers. As a company, we have really specialized, I would say, in segregating material. So with waste to energy, the traditional view has been to set up very large mass incineration plants where everything goes into the incinerator and everything gets destroyed and energy gets recovered. And while this has been successful in other parts of the globe for more than 20 years, I think the need of the hour now is to sort everything that's recyclable and only burn something which is non-recyclable. And so as a company, we've spent the most amount of time in developing a pre-process which is suitable to the Indian context. As some of you may know, India does not have a very high level of source segregation right now. We are getting there. But in this period, we need to do a highly efficient mechanical sorting. And many people ask me that, what is the technology curve in waste to energy? So, in the solar industry, we know there is a cost curve. In many other industries, there is a technology curve. I think in waste, the big technology curve is around sorting, because you have technologies like machine learning, artificial intelligence, robotic sorting, and already we feel we are reaching a point where mechanical sorting competes or is cheaper than manual sorting and obviously more efficient. And I think in the next 3 to 5 years, it will continue to get cheaper, enabling the types of business models we are doing. So using these technologies, we intend to separate out all the plastics. Whichever of those plastics can be mechanically recycled, we would be doing that and creating granules. Even with mechanical recycling, you hit some end of life where they can no longer be recycled, retaining the functional properties they have. In those situations, they would be moved to chemical recycling or energy recovery through incineration. And then the last circle you see is where we will use the wet waste to generate biogas. And wet organics have historically gone into the incinerator for energy recovery. But all of us know that they do not add too much of net calories because they're so wet. So most of the energy goes to evaporate their own water. Instead of that, if these can be sorted efficiently and can be put through an anaerobic digestion process, which is a wet process, then not only do we recover energy in the form of renewable natural gas, but we also get organic carbon, which can go back into the soil to fertilize the soil and hence becomes a closed loop sort of cycle. This is a view of our Jamnagar facility. And on the left, you will see what we are doing right now in terms of the waste to energy plant, what's been running for the last 2 years. And on the right, you will see all the projects under development. And so you will see that when this campus is fully developed, it will become India's first fully integrated waste management campus. And as Steve alluded to it, I think we've planned for the space, we've planned for the process. So we've gone in and built this business with this view of where we want to be and what is the first step that can help us get there. As I said, I think the technology curve in waste is very, very interesting. And I think this exists right from sorting, where you can have barcoding of waste, GPS-enabled collection, monitoring centers to see how the collection system works. Once the waste comes to a processing plant, then I think sorting is the big change. So with machine learning now, you can imagine waste going on a conveyor and a camera sitting on top of it, and you can teach the camera to sort whatever you want. So you can tell the camera, I want to sort out all plastics. You can go a level further and say, I only want high density plastics. Or you can go even a step further and say that I only want to sort plastics of a certain brand type, which can go back to make packaging for the same brand again. As a company, I think we've been at the forefront of piloting some of these technologies. And we are very excited about how these combinations of machine learning, near infrared, Internet of Things can really change the way we view waste as an environmental burden, and change that view of how we can view it as a resource which goes back to create newer and newer materials. So I think this is a view of what the final waste campus will look like. So you have incoming municipal waste, which goes through a very extensive pre-process, including a material recovery step. From that, you get a recycling value stream, which you can use to create new products again. Whatever is left goes either to energy recovery through biogas, which is for the wet waste, or to energy recovery through waste to power, which is through a combustion type process or an advanced thermochemical process. The byproducts that exist, such as the bottom ash, which is generally non-hazardous in nature, we plan to use to make construction material. We've already piloted this, made materials, gotten it tested. I think quality is working well. So I think this part should also be commercialized very soon. And then this waste management setup can also provide service beyond the municipalities to either a cluster of municipalities, to solving the agro waste problem, to solving the industrial waste problem. So this is really an expanded view of what historically used to be just a waste to energy project. So the waste to energy project remains the anchor project in this campus, but there are various bolt-on projects which create this ecosystem. I think spending a few minutes on the technology that we've developed. So I think, the philosophy that I have articulated is possible only because we can segregate material. And as a company, the approach we followed is first gone in and understood the waste. And we've spent a good 2 to 3 years just characterizing waste, using it on a pilot basis, seeing how it behaves. What does it have chemically, biologically? How does it break down? How does it burn? What is the residue it leaves behind? What sort of sorting methods does it respond to? So sorting can be by size, it can be by bulk density. There are various ways of sorting material. And through using a combination of these technologies, which are suitable for the Indian waste context, we've created a proprietary process technology for which we have a patent approved in India. And so I dare say that this is India's first homegrown waste technology, which enables us to build plants which are more than 80% Indian. Hopefully in the future, we will go close to 100% Indian. So it starts with the process, which is the secret sauce of the whole thing. The advantage we get from this is the waste going into the incinerator also is of a higher quality. So, it's not your typical mass incineration raw municipal waste. It's RDF recovered of a higher quality. Because of this, we can also make the boiler more efficient and simpler. And we have done that. And what we are using in Jamnagar is an Indian-made boiler, which uses a suspension-based firing technique. It's a spreader stoker boiler with a traveling grate. So quite different from the general mass incineration reciprocating grate boilers that you will see. And this type of approach also has significant advantages on air quality. So I will come shortly to the next slide. If you look at our business model, then the waste is locked in with a 25-year contract with the municipal corporation. The output power is locked with a 20-year contract from the government power company, which buys the electricity. And we are interested to set up the project, invest the capital, run the project, and really recover our capital investment with disposing waste and converting it into products. The ash that gets left from this process, the bulk of it is non-hazardous and can also be used to create construction bricks, paver blocks, or other types of filler materials. As I was saying, our proprietary process has undergone a lot of research and scrutiny in terms of the effect on emissions. And the key difference with our process is in our boiler, waste enters at a high temperature zone. So you will see in waste boilers, it usually starts with a drying phase, which is relatively low temperature. And that low temperature point tends to create pollutants which need to be captured later in the flue gas treatment process. So while we have and we follow all the steps of the flue gas treatment process, the burdens are much, much lower because the entry point of waste itself is at a high temperature. So I think as a company, to conclude, our philosophy has been to look at waste in the local context. And just like this is applicable to India, I'm sure this is applicable to many developing countries globally who have this problem. And I think rather than just, I would say, importing or, following systems that have worked in the West, they have worked in that context, but developing countries have a different context, have different economic constraints. So we've really tried to look at those constraints and create a model that works in the Indian context. Secondly, we have looked at waste as a whole. So we have not looked at it from a single solution perspective. And I think in the waste industry, many of us get drawn into these debates of whether this is better or that is better. But I think everything is required, everything has a role, and everything is complementary. So we've chosen to look at everything together and really start with a very strong sorting process, which optimizes what type of recovery we can do from each type of waste. And I can dare say we've made a good start. Jamnagar is a green shoot of success for the industry. We are in advanced stages of construction of 3 more projects in the state of Gujarat, the cities of Ahmedabad, Baroda, and Rajkot. Once these are complete, then more than half of Gujarat's waste will be through a circular economy process. And of course, we hope to take our learnings to other states in the country and someday to other countries in the world as well. So I will stop here. So once again, thank you to ADB and to Steve to give us this platform. And thanks to all of you for listening patiently. Thank you.
Thanks, Aditya. That was wonderful. There's 3 words that I really liked in your presentation, which stuck out to me when I visited the plant with Pankajji in January. Consensus building process. Can I ask you to talk a little bit more about how you did that? That I think is something very important to the way you work.
Sure. So I think, in the waste industry, we've always faced what is called NIMBY, not in my backyard. So, everybody wants waste to be cleared, but not necessarily near where they are living. In the Indian context, it's slightly different because there are already mountains of waste where people are living. And so when you go in and try to say we are doing a new type of project, the suspicion is that this is going to make the problem worse. And we need to educate people and carry them along to explain to them how this is going to make the problem a lot better. And so we've done that. We've done a lot of community engagement. And if you look at the way we've built our plants or our campuses, each plant has a community engagement spot. It could be in the form of a sports field where people can come and play a sport, or it could be community engagement in terms of cultural events. We've consistently got, school-going children to come and visit plants. And so we want to send this message to society that there is a modern, technologically advanced solution to waste available, and they should support these sort of projects. And we've seen that. We've really not faced any significant social issues in any of our projects. Similarly, there has to be technological consensus. So it's not easy to use one campus to set up 3 or 4 different types of waste disposal methods, because each technology has its own sort of input criteria. And you can imagine there's a lot of haggling about, what will the boiler get and what will the recycling machine get, etc. And I think, in a nutshell, our thought process has been a series of trade-offs. That is what I would call it. Our decision-making has just been a series of some very good trade-offs where we've tried to optimize a lot of variables. And I think that lends itself to a collective process, because you can take good trade-off decisions only when you have multiple voices sitting together. And hence that's been the approach and method that we've followed in our project development.
I was going to actually, Pankajji, I'm going to ask you this question directly, sir, but let me just respond to one thing. Joe Huang, we'll come back to your question in a minute, because I think it leads on to what's going to happen now. We'll lead on to it. So, Mr. Pankaj, Can you talk a little bit about the processes you did in Amanabad? I remember you sharing some of that with me, and what are the sort of people, who are the sort of people you're engaged? How do you make sure that you've got a representative sample of everybody who's involved?
Yeah, so thank you very much. And Aditya has covered almost all the aspects. Let me touch about some aspect on how we conceptualize the campus, So in last couple of years, we visited many plant outside India. We spent few hours, few days there in understanding the not only waste, but the overall approach on the layout. Then we studied the need for sustainability, we studied the SDG goal, etc. And then we realized that we can very much integrate while in our integrated waste management campus. For example, we have decided to use either we harvest or we use it all rainwater, So we have created the, excavated lagoon with our own, the soil. So we have not thrown any kilogram of soil out of my campus, nor we have brought any soil from outside into my campus. So we did soil conservation with, we created water body to collect the rainwater. At the same time, we have a misting arrangement instead of normal cooling tower. So whatever vapor goes out of the cooling tower, we want to retain inside the campus so that we can nurture the green landscape. We have created ultra density mini forest into the campus so that any school going children or any citizen, if they come to see our campus, they will have a different experience while they move in and out of our campuses. One thing Aditya has forgotten to mention is that we are not going to use any fresh water, either from borewell or the pipe water. We will use city grey water. So all cities in India, like solid waste, we have an issue of how to use efficiently city grey water. So we are one of the first pioneer in our country to use STP water for our non-edible cooling application in our campus. So we will use city grey water. We have not allowed any, so rainwater. We have also tracked the sun movement. So the orientation of building in such a way that even in a bunker, if you are operator, if you are sitting in the the grab operation, to stay in the bunker for 8 hours is you are like behind a bar. So we have created the glazing view, so one can see the center of the campus even sitting inside the bunker. And in the morning, you receive this rays of rising sun inside the bunker. So it will destroy the negative energy in terms of thought or ambience. And during night time, visitor who is passing by, they can see it is like a car showroom, So the grab is doing tumbling of municipal solid waste, and you as a visitor, you can see something going interestingly, So we try to create a attractive proposition, not only for our visitors, but also for our teammates who are going to be there for a long time. At the same time, as Aditya Bhai said, we are not only focusing on only waste, but we are also focusing on multiple value chain recovery. So for example, one thing I would like to add here is, for flue gas cleaning system, people may use caustic like or any other chemicals, right? What we realized while doing our testing on fly ash, we realized that it has about 30% alkaline element in it. So why can't I use this alkaline element to control the acid? So we have used this fly ash, we dissolved in a STP water, we filter it, and now we are using this concentrate with high pH to control the acid. Otherwise, in conventional way, the conventional method is you buy caustic lye or other absorbent to control the acid fumes. Similarly, we have done a lot of things about the CO2 capturing, but that is way forward. As Aditya said, first priority is power from renewable source. Second, focus on circularity. And third, in his slide, CCUS. So we are highly prepared to grab that opportunity in coming years. And when we have designed this campus, we have kept key thing in the mind. There are a lot of seasonal variation. We are located in a hot climatic zone. And the children love to have a water sport, And Ahmedabad is a dry city in that sense. We don't have
very dry.
coastal region. So in a mist area, we have created, we are circulating 4,000 cubic meter through a mist, and you can wear the raincoat and walk through. When you walk through, you get sound resembling Niagara Falls. So it is a thematic element we have added while we process our waste, and children will come to feel that while they are there. They will also see what is going inside our plant, because this plant is built for 25 years. So whatever waste characterization we do of past does not mean it will remain the same in next 20-25 years. So it will be a dynamic activity and forever activity for our team to operate. Thank you.
When I visited you, I mentioned, and Joe, I'm coming back to you, I promise. But this is a very important point. When I visited you, I mentioned that people don't think of waste treatment or in any of these forms as like shopping centers, where you have a shopping center, and if it's a big shopping center, you might have two key tenants. One might be a cinema and one might be a shop, like a supermarket.
Right.
If it's a smaller one, it might have a supermarket. But that's what drives the traffic to the smaller activities. But what I like about the way that you've approached it, and you saw me smiling when you talked about this, because if you had have told me this 5 years ago, I thought, well, this is a bit strange. But actually what you're doing is you're embedding this piece of infrastructure and changing it from being something sort of dirty and unpleasant into being something that's a community focus. And the project in Denmark, where they put a ski slope on and a climbing deck, I took the same approach. You're just doing it in an Indian way. And I can say that without sort of sounding negative or anything, because you incorporated the elements of what people in India want to see. And I think that was the really strong part of what you're doing. It's a great business. It's going to make a lot of money, but it's also a beautiful business. And I commend you and all of you on your work. So now we have to go to questions. So we've got, sorry,
last
please.
point. While building the campus, we have calculated how many bricks we have consumed it, how many steel we have consumed it, and we have taken that environment liability in our account. So when we start, from day one, we are not carbon neutral, but with passage of time, we will cut our liability in say about 2-3 years. So we have a books of account, I would say, that how much carbon dioxide we have emitted because of our construction of the plant.
Walk the talk, baby. Walk the talk. Rock on. So now we're going to go to the Joe Huang, who is very patient. Joe, just to answer your question, I'm going to ask you to actually talk about, I'm going to ask you a question after this, and so get ready to get online. ADB is doing a lot of work in plastics in Indonesia, and there may have been a few large admissions, like press releases. And I'll put you in contact with some people who can work on that. But my question for you, Joe, is how would you make this sort of approach work in Indonesia, which obviously has very strong Indianized elements in its culture, but also very unique in Indonesian cultural elements? I know you've been there for many years. I'd be interested to hear your thoughts, mate.
Sorry, Steve. Question about the culture.
Yeah, culture. How would you embed one of these facilities in the same way that this has been done in India into the Indonesian culture?
Basically, we already have a private sector company that has received concession to treat 1,000 tons of waste every day in West Java. So the company that got the concession is focusing on RDF. So there's going to be 500 tons per day of organic waste, food waste, that can be converted to biogas and bio-CNG or bio-compressed gas. And we also have buyers for this biogas or bio-CNG fuel. So basically, what we just need is finance. So it's straight business case, Steve, that can be implemented very quickly. Thank you.
Okay, Joe, we'll take this offline. I'll put you in contact with some people who can help you, mate. Okay? It's good to see you, Joe.
Thank you.
Take care, mate. Kin Chan, another very experienced Indonesian operator. Sir, can you ask your questions?
Hold on, Steve. Hi, everybody. Just switching on. Hi. Thanks, Steve, for inviting, and thank you for the presentation. Extremely informative. Just got a couple of questions. Really, a lot of it. First two really relating to the concession agreement that was referred to earlier in your presentation. I think, as most of the people know, such supply agreements are really critical for success of these type of projects. So I really wanted to understand a little bit deeper about what you've managed to agree with the waste supply, in this case, the ULBs, both from a perspective of, how is the race characteristic changes being managed as a risk in that concession agreement? And secondly, in terms of that supply agreement, who's going to be taking the risk? How is the kind of ULB going to be managing the risk of downtime is my question there. There will always be downtime, sometimes unplanned downtime. So I just wondered how that is going to be managed, by the ULBs, and how is that crystallizing into the concession agreement. And the third question, really, again, a kind of more, a key risk for these type of projects is about the available land, the site and location, the size, its relative location to sensitive groups, areas, peoples. What was your experience when you were choosing your site in Gujarat? And again, how did you fund it yourself? Did you procure it, or was it kind of something that was provided for by the ULB? Just wanted to understand a little bit about your experiences on that part, because certainly going back to Steve's point, site location is a very big issue in Indonesia. On all the projects I've worked on, I'm familiar with, that has been one of the big impediments. Certainly my last project got sidetracked because of the land issue, and it's always been an issue in all the projects I've seen. So yeah, those are the three questions. I appreciate responses to those. Thank you.
Sure. Thank you. I think all very good questions. And as all of us in the industry understand, these are the determinants of a project success to a large degree. So I think in terms of the concession, we've been fortunate to be able to negotiate that there are a certain defined number of days in a year where we can keep the plant under maintenance. And that is really at our discretion. And the number of days vary by concession. So I'm not going into the exact number, but that gives us some leeway to obviously have planned maintenance, but also some cushion for unplanned maintenance if possible. Beyond that, obviously, we have to start paying penalties. Fortunately, we've not had that instance so far, but that's how the concession is structured. And I think this is where the baseline matters. So if the baseline for the city is all the waste already being disposed, then they would want a very, very high uptime to make sure that continues. But if the baseline is where everything is being open dumped, then most things are an improvement. So there is therefore some allowance of a few number of days a year when one can keep the plant down. To your second point in terms of quality risk, so I think there is one type of risk which is contamination risk. That is on the municipality. We don't take that risk. So there are clear directives of what waste they can give and can't give. So for example, they can't give construction demolition waste, they can't give hazardous biomedical waste, and they have to collect all of that separately. But within household or commercial municipal waste, there are no further quality assurances. So we will get everything mixed is what we have to assume. With time, as source segregation improves, I think it will continue getting better. But as a worst case assumption, we assume that everything will be mixed. And hence the type of pre-process we've designed is actually not very static. It's a very nimble process. So, there are various parameters, the size of the screen, the loading rates, the running speed, the sizing of the shredder, how small do you want to make it? So there are various parameters when taken in conjunction, you can change or you can respond to the incoming waste quality. So I can tell you that, for example, when it's raining, our parameters are set up very, very differently. And when it's dry season, India is very hot. So waste quality is good in terms of moisture. We want to optimize cost, and hence the parameters are set up very, very differently. And across energy recovery and all the other things that we want to achieve. In terms of our growth trajectory, I think we've been lucky that, we found early funding, which was patient enough through some family equity, some project finance, etc. And now that we've set up a project, run it for 2 years, there's, demonstrated success. And as we are growing, I think there is opportunity to raise capital to fund these sort of projects. I think everyone recognizes the gravity of the problem, and hence there is capital wanting to come in. They just want to see that, there is early success. The team that's handling it is knowledgeable, they know their stuff, they can make it work. So now that we've passed that phase, I think we are in a better sort of zone to raise growth capital and grow our projects.
Great. Thank you for those responses for the first two concession-related ones. I think actually it's extremely good to hear how that you've managed to utilize those kind of relaxed kind of financing sources to give you time to undertake some of that upfront analysis. I think that's critical. It's a very good lesson learned, I think, for all of us in terms of, and certainly for me to hear that the private sector with the right type of financial backing is able to do that analysis. Because I think what we see as ADB, and it's quite typical in developing countries where the governments, the ULBs in this case in India, really don't have the time or the capability or the resources to do that analysis. And typically they go to market without that type of understanding. And that really does affect the kind of bankability of these type of projects, the feasibility of these type of projects, both technically, financially, and legally sometimes. So I am heartened to hear that the private sector can do that. And actually, Steve, is probably something we should think as ADB about. How do we enable some of that kind of private sector analysis, instead of just always pushing with on the upstream side with government, which, as we all know, is sometimes very difficult to do. Maybe it's also a good example how to do it with private sector. So thank you so much for that. That's really informative.
Just for information,
I think you wanted to raise your hands.
About the waste characterization, Mr. Shan, since inception of Abellon, that is in the year 2008, we have been doing waste characterization of almost 15 different cities of Gujarat on chemistry, physics, and biology, number one. Number two, when we have configured the plant, most of the time we will have a 2 boilers. So 2 boilers working at a time. So if something goes wrong with 1 boiler, at least 50% plant is available. Number 3, this plant can not only accommodate repair RDF, but it can also accommodate agriculture waste in case waste is not available of that quality. So we don't need any diesel or gas or oil to do over-firing or fine-tuning the temperature. So we can plug in the agriculture waste and also some approved industrial organic leftover, which are a burden for industry, we can blend to some extent. So it is more versatile in terms of fuel flexibility.
Thank you so much.
Ken, one of the things that struck me in the last year, I'd spent a bit of time in India, is the change in the way that government and business and everything sort of happens. And it's not a case of, it's just all driven by government and everybody just does what they say. It's quite different. There's a very different feeling of the possibilities of India. I think that's and I know this may sound a bit strange, but there's a case of, instead of being, that's not my job, I don't care about it. It's a case of, okay, let's have a look at it. I'll have a try. And so what I really liked about the way that this was approached was that people would go and speak to, for instance, the local authority or the river authority or whoever, and they'd listen. And I think so much of what we've experienced previously is where people don't want to listen. It's not their responsibility and they don't care. And there doesn't seem to be that political drive or that social drive to make these things happen and make them happen in a way that is beneficial to everybody, as opposed to not engaging with people and trying to get it through as quickly as possible, which I think is a recipe for disaster. because you end up having pieces of equipment that end up having long-term grievances from stakeholders and all sorts of stuff. So Ken, you've got a very interesting job. You might want to just identify to our friends exactly what you do at ADB.
Sure. Apologies. I should have introduced myself. I've been with the bank for nearly kind of 5.5 years now. I spent most of it working on PPPs because my background is actually in PFI back in the UK, where I worked in some of the kind of early PFI deals in waste management. So I worked at Veolia, Verdor, all of those people, Grundon, all of them. So waste is kind of very close to my heart in my kind of background. So I've just taken up the new post in our Indonesian resident mission in Jakarta. So I am the senior infrastructure specialist there. Although it's a very generic role, my real remit is to kind of join the dots between our sovereign and non-sovereign businesses operations in the ADB, to try to enhance the way that the bank is able to support infrastructure development in Indonesia. So clearly, waste management is one of those areas that I'm very keen to work on. So hearing some of your experiences will help. And if it's okay, I'm sure I'll be reaching out to you through Steve to share some of those of my Indonesian counterparts in government there, as Steve alluded to. Some of those listening issues is something we still have to overcome. But the government, I think, does recognize the issue in Indonesia. It's quite a big one. But I think the progress has been slow. So I think learning, I think as Steve's mentioned about, how India's private sector, has kind of engaged in a kind of more direct way, and to kind of build its own business in a way that addresses some of those underlying risks by themselves is quite interesting.
Yeah, sure. We'll be very happy to engage and exchange learnings. And as Steve has said, I think Indonesia has many similarities, both culturally as well as the type of country, population size, etc. But I'd like to pick up on what Steve said earlier. I think in the last, 5 to 10 years, India has demonstrated that it has the capacity to do large projects. And, to talk about the waste sector, just 5 years ago, the total government funding in the waste sector was about $4 billion a year. Today, it's about $20 billion a year. And, some of you may know the famous speech that Prime Minister Modi gave from the Red Fort on Independence Day, which is the keynote, sort of address of the Indian Prime Minister. And he said, we have to clean up the country from the Red Fort, no less. This equivalent to the State of the Union address in the US, you can say. And people were amazed that, how can you, in a formal occasion, how can you talk about clearing waste? But he said it. And then he made the funding allocation 5x. And Swachh Bharat, which is the flagship regulatory and sort of policy, is enabling all these projects. So yes, I agree that there's a new resurgence and confidence that we can actually build these sort of projects, make them successful, and we'll be very happy to engage and share whatever. There are sort of many nuances which we've not covered today. So because India is so diverse. There is a specialty cell that only works about collecting waste from high mountains in the Himalayas, right? There is a cell that specializes in waste collection on islands, which I'm sure is relevant to Indonesia as well. So I think there are these pockets of learning that have occurred, and because India is like a laboratory of different environments, all these learnings can be applicable in many developing economies of the world.
Yeah, I think it'd be good to also share some of the, I mean, the waste industry's got a bit bashed around over the last 15 years with things not happening and, people having big desires to do things and then other people having views about not letting them do them. There's been some rightful pushback on the quality of incineration, which I think ADB has responded to in a meaningful way. Talking about what is the right size. And I like the fact that you're not burning everything, which some of our countries try to do, and saying, there are better solutions. I mean, sticking organic waste into an incinerator is a really bad idea because all you're doing is boiling water, and then you're not capturing any of the flue gas. So from our point of view, we regard an incinerator as a plant that is basically a waste to energy plant without the gas recovery. And we won't fund that. We won't touch that with a barge pole. So, the sort of projects that we want to look at. So are there any other questions that anyone else has? We're getting to the last 4 minutes. Any other questions from the floor? Okay, well, look, what would be, Okay, what would be really nice, Aditya and Bangaji, is to maybe get a video of the facility in Ahmedabad and share that with us and just do a walkthrough. That would be really nice.
Sure, we can do that. Happy
Yeah,
to.
okay, great. Well, look, at that note, I'll say thank you very much to everybody and thank you for your presentation. And we'll look forward to hearing more about your successes. So on that note, thank you, everybody. See you later. Bye-bye.
Thank you very much. Thank you.
Everyone. Thanks, Steve.